Okay, here's number 55. We want to see whether the vectors in B are linearly independent and if they span R3. Okay, here's B. Is B linearly independent? Well, what do? We set C1 times the first vector plus C2 times the second vector, and then so on. We set that equals to the 0 vector. Okay, and then we solve for the C's. Let's make the matrix. Okay, here's the augmented matrix. We're solving for the C's, and if I reduce this, then I get, okay, let's see, what is the first row? What is the meaning of the first row? C1 equals to 0. Second row, C2 equals to 0. And the third row means C3 equals to 0. Yeah, we have 3 variables. So that's the trivial solution. So the conclusion is yes. Right? Yes, B is linearly independent. Okay, second question is, does it span R3? Well, let's see. What do we do to show that a set spans a vector space? Well, we pick a vector in the vector space and see if we can write that vector as a linear combination of vectors in B. Okay, so that's the idea. Okay, pick a vector U in R3. You cannot pick a specific vector. You have to pick a general vector, right? Because we want to show that all vectors in R3 can be written as a linear combination of B. That's what we want to see if it does. Okay, so now we write U as a linear combination of the vectors in B. So we set linear combination equals to ABC. And then again, let's form the matrix. Right, I'm gonna copy this thing here. It's gonna be kind of similar, but instead of 0, 0, 0, I should have A, B, C, right? So this would be A, B, and here is C. Okay, we can solve this by hand, which is not that bad. Or you can use, well, you can't plug this in the calculator, right? You could solve this by hand. Look at the last row. Last row says the C1 is actually C. Look at the second row. It says the C2. Well, you know what? I'm going to write C1 equals to B minus C2. Okay? So this way I can combine these two and solve for C2. And look at the first row. I have C3 being A minus C1 minus C2. Okay, let's play with these two here. If I subtract them, I can get rid of the C1 and find C2. Okay, so the first minus the second, I get 0, and then B minus C2 minus C. I subtract the 2. So here it is. C2 equals to B minus C. Okay, and then look at that. I found C1. C1 is C. C2 is B minus C. And C3 is A minus C1 minus C2. Okay, in other words, I found C1, I found C2, and once I found them, since I found them, then I can find C3. Okay. So um, we found, or there is a solution for the C's. Okay, so that means we were able to solve this for the C's. So B spans R3.